Welcome again. This is part 2 of your instruction video on qualification testing. You should look at part 1 if you are jumping to part 2. We're talking about semiconductor qualification testing that we've selected here, and we've entered our initial things for our project names and things like that, and we're starting off with temperature cycling. And so the first thing we've done is we're entering our 200 cycles, the low and the high temperature for temperature cycle testing. We do the same for temperature humidity bias testing. We're going to say we do 1,000 hours at 85, and our use in stress, our use is 40% relative humidity and that temperature 25°C. And we do the next thing for high temperature operating life, and you want to put in the junction temperature and things like that. So basically you have 1,000 hours, the test temperature, and the maximum use temperature, and the junction temperature. So it gives you the HTOL junction temperature here, and your device temperature at maximum use. So there's your, and you come down below, and you're going to enter for the semiconductors okay. This section is not applicable for semiconductors. And then we have our ESD testing. Whether you want to do that, you put a yes and the number of units that you want to test. And down below here is your results. So it shows you for temperature cycling, the optimum number of units that are needed to be tested is 8 for temperature cycling, 12 for temperature humidity, and 26 for H2L. Here's your ESD and others. And there's your objective. Now remember, we started off at 60% confidence, 400 fits. If we went to 90% confidence, everything would jump up. So we're going back down, and we see that the sample size has increased. Now you also, you're saying, well, what are our test parameters, and how do I control that? Well, here are the test parameters that were used, and you can change these. You can hyperlink down to change these. We've entered a 0.7 activation energy, a 0.9 EV for HTOL. So, for example, if you want to be more conservative, you hyperlink down. It's just down a little bit lower. And you can put in your model parameters. Say for H2L, I wanted to use 0.7, which is a little more conservative. So now I go back up, and I see my sample size for H2L has jumped up to 162. Now, what if I want an override? I want to put in my own objective and things like that. So I don't want to put in 162 here. I want to test, say, 100 devices. So I put in an override here. And notice, once you put in an override, it's going to come up with that sample size and say you're no longer at, it's going to cross out the 400 fits that you put in originally, and it's going to tell you with those 100 sample sizes that you changed, your failure rate that you're going to achieve now is 571 fits. So you've obviously reduced your sample size, so your fits has gone up. And you can play around with test times for that. Say you say, well, I want to go back to the 400 fits, so you can maybe increase your test time to 2,000 hours. And we'll go down and see what that does. And now we're closer to the 400 fits again, and we've increased the device hours to get there. So that's for semiconductors, and we've done the ability, you have an override. If we take the override out, we go back, and the optimization routine kicks in for that test objective of 400 fits. And okay, so now once we've done that, all the sample sizes will not only show up here, but they will populate on your process flow card. So now we have a total of 181, which was your total sample size, because you had these for your testing, you had your ESD, and you had others. Now, the others are shown on the process card. What those are, those might be related to, say, on your process flow card, it could be related to destructive physical analysis, for example, or physical integrity, ESD testing, things like that nature. and you have your X-ray for your. It suggests what to do for destructive physical analysis: X-ray, CSAM, deprocessing, a bond pull, and not only that, but it hyperlinks to recommendations for bond pull and die share and things like that. So if you don't know how to do what bond pull, you're at a loss for that. It provides you the JEDEC spec as well as some recommendations. If we go down here, you'll see quickly the hyperlink to that. Let's go to that hyperlink. So recommended. There's your die share, your gram pull force, and things like that it's recommending. So that's your semiconductor stuff. Now let's go over to the hybrid testing. Similar kinds of things for your input format. For your hybrids, the first thing you're going to the things that are different are down below here from compared to your semiconductor inputs. A similar kind of entry for the semiconductor input, but on the hybrid you're going to ask the questions: are the units too large to do constant acceleration? So constant acceleration, so let's say they are. Then if they're too large, you're going to enter a vibration test level. If you say no, it's going to recommend, it's going to change everything, and it's going to ask you, it says enter sample size or leave blank for a calculated sample size. So you can override that. And it tells you right here it's going to recommend 4 samples. Also for the hybrid for ESD testing, you can have the option to do that or not. So then you have again, the parameters are provided here. Here's your confidence level for the test, the parameters that were used for that, and here's your confidence statement about what you're achieving, as well as you can make some changes for your model parameters that you're using. And the process flow card will, for hybrids, you scroll over. You can copy and paste these, and you can delete things. And there's your sample size inputs that are populated on your card, and your test that is done. Notice on the last sheet, which I forgot to mention for semiconductors, it does print out all your model parameters that were used in your what levels you're doing 400 fits for the hybrid, 90% confidence and 0 failure testing, for example. And finally, for assemblies, if you select assemblies, similar, you have your inputs. By the way, when you put these inputs in on the process flow card, you'll come over and you'll see your inputs here. And right on the top of each card, it says the test manager is Bob Jones, and here's the date that you put in, and this is the unit type that you specified, IC123. Obviously, for assemblies, you wouldn't be using IC, so you could put assembly 123, and that would show up on your process flow card for assemblies. And the same kind of input here. We're kind of running out of time, but here you're going to do vibration testing. Enter Y to perform vibration testing. So if you put yes, then you have to explain what test you're going to do, and it has a number of recommendations and the level and the fractional amount of life that you're going to do. And then it comes up with your results here for your failure for your goals. Notice the goals are also specified here. If you don't know what goals to use, here are some specified goals here for hybrids, assemblies, and semiconductors, and it gives you the test objectives, some basic ideas for depending upon how many components are provided. Again, just to wrap up, keep the video down to 10 minutes, so we're almost done. Assembly process flow card is provided here with the assembly name and things like that of that nature. And there's the process flow card and the state expected conclusions that are provided here from DfRSoft and your flow chart. Thank you very much for, so DfRSoft makes design for reliability a lot simpler for qualification testing for semiconductors, hybrids, and assemblies for whatever you're performing. And if you have any questions, because we went through things fairly fast, give us a holler through our website. Thank you very much.